So welcome to Econometrics Melody. In this tutorial, we'll deal with two-way bar, two-way rbar, two-way histogram, two-way area, and two-way rarea plot types in Stata. So let us prepare our data set. This is the data set that we are going to use for this tutorial. And our first type, plot type, is two-way bar. So we have already dealt about the one-way bar graph in our video number 4. Please refer to it. And let us see how does this two-way bar work. We are specifying two variables, income and export. Export is going to treat as an X variable, and the variable preceding the last variable, they are treated as the Y variable. So income and export. So we can get the similar result. So this is like a spike graph, but we can get the similar result using other plot types as well. And let us see and compare them. So this is the result of income and export, and we have used a bar plot type, spike, scatter, and we're getting the same result. We can always manipulate the width of the bar. So here we have manipulated bar width 93. So this is the result, and when we compare it with the initial one or the default one graph, and we see the differences, we can increase the bar width. Similarly, we have other options, and we can use these options to manipulate other styles as well. And let us see, these options consist of vertical, horizontal, base, bar width, bar loop options. We have explored in detail about the bar loop options in our video number 4. Axis choice options, two-way options. There are similar options, and let us see about the base. So if we specify income and export, we are going to draw bar of input and export. Base is 0, bar width 93, y line, and let us see what does it look like. This is our base actually. So we have drawn y line at 3000, and now let us take that 3000 at our base, and let us see what does the bar graph look like. So this is actually the deviation of the y variable from 3000. So excess of 3000 above this line, and beyond this line deficient of 3000. And if we combine it, we will see the y line at 3000 will coincide exactly, and we can explain it in a similar fashion. Now let us track the movement of a variable over the period. So we are going to create a difference of export variable. We are going to quickly summarize it and store the mean of it in a global variable. Now we'll make use of this global variable mean difference to plot the y line, and we're again going to draw the bar graph of difference and the symbol number. So this is the deviation from mean of this variable difference, which represents the first difference of export. Similarly, we can plot the export variable by the help of connected plot. We are going to plot the export variable. So connected plot, export and symbol number, and then we are going to plot in the similar. Actually, we are going to combine the bar graph of this difference of export in the same graph, and these are the simple style, marker style, and these are the y scale and y label styles. Now let us, in the same graph, let us plot the export value as well. So this is the export value represented by orange color. So orange color, and the bar graph that represents the deviation. Actually, it tracks the movement of individual observations. Here decline, and the second of the movement, it is the increment, and so on. It tracks the movement of each observation. Now let's drop them all. Another variation, let us sort the variables or our data set by district, and by district let us create the mean income, and we have the mean income of mean income according to our district. And now let us, so if for the female gender is equals to 0, for female we are going to substitute their mean income values by negative values, and we are going to plot the bar graph of income according to district for each gender. Gender 0 means female and gender 1 for male, and we have this negative value will help us alter the bar graph. So horizontal, so the direction will be shifted. So for male, these are the positive values, and for female, by default we have enforced, or we have forced it to be negative. That is why the direction of horizontal bar graph for this gender, for female, it alters. And then we have labeled this minus figures over here. We have covered it by the label. So minus 4,000 is represented by 4,000 plus 4,000 and so on. All the minus denominations, we have covered it by the positive labels. Now it is easy for us to compare the male income and female mean income across this district. Similarly, we can label this districts at this place where x is 0 and both the base of the bar graphs, they are coinciding at this place. And for that we are going to create a variable x is equals to 0, or a 0 variable, and then our y variable, it should be from 0 to this 8 and their respective level. These are the levels of the districts. And in the above graph we are going to use this scatter, so y position and 0, and we label it by the district level. So this is our district level variable, and these labels will be plotted over here, and we are going to add some fine styles, and we will see this result. So 0 1 2 3 4 5 6 7 8, the scatter of 0 1 0 2 0 3 0 4 0 5 and all the way to 0 8, and we have labeled it and provided some styles. So these are the styles. And we know by now we are familiar with marker styles, marker symbol style, marker label styles, and X, Y, scale, label, and title, and so on. Now let us drop them all. Now let us move to another plot type. Plot type, it is a range plot with bars, rbar. So range requires 3 variables: high, low, min, max, confidence interval, and so on. And let us see it for ourselves. So what are the possible or the types of range plots that we have seen? These are the different types of range plots that we have seen, or we cover in our coming videos or tutorials. And if we combine them all, we will see they are representing the same information and in different format. They are the different plot types, range plot types, but all the variables, they require all the plot types, they require 3 variables: x variable, and any variable preceding the x variables are the y variable. These are the options that we can use for r bar, range bar, so vertical, horizontal, bar width, mean width, and we have already gone through these options. Now let us see, we are making use of 2 plot types, r bar and connected. So r bar represents the high low, and connected represents the close price. In our previous video also we had drawn this, and we try to replicate the similar result by using other plot types: r cap sim for high low and symbol number, and connected for close and symbol number, and we should be able to get the similar graph. So they are relying the same information, so they are similar. And let us drop them all. Now let us move to another plot type. To a plot type, it's a histogram, and by histogram we plot the histogram of one variable, income, and here we have specified income for observation 1 to 30. The histogram, this is the histogram of income, and this is the default figure. So y-axis, we get the density, and we get this bins, 4 bins, but we can manipulate them according to our size. If we specify this option called discrete, now they will be treated as discrete observations, and again the y-axis has its density plot. Now if we specify bin, the data or this will be treated as a continuous variable. And did we specify the number? Bin number is 12, and if we count them, this should be 12 including these missing variables. And once we combine it, we will see the differences, and it is easy for us to compare. By default we get this result for the same variable, for the same condition. Discrete will turn it into discrete observations, and bin will treat it if the data were continuous. Now let us see the options. We have discrete options and we have continuous options, as well as the common options for. These are the very simple options. Now let us explore some of them. With histogram, so we have, this is our discrete, and this is a unique identifier. Once we mention discrete, so the graph, the histogram will be a discrete histogram. And frequency, now change in the y axis, it represents the frequency, and bar width is 100, start is 9, the minimum start is from 9, and so on. Now let's explore the other one. Is it continuous? Bin 6, so this specifies the continuous. We get 6 bins, bar width is 100, it starts at 9, and frequency, y-axis represents the frequency. And to check this, let us see what is the frequency of the observations. Less than 4,000 over here, and less than 8, it is 5 plus 3 is 8. And let us see if we get that result or not. So 8, here it's 8, and this is true. Once we combine it, we see the differences, and this is very simple by now. Yeah, this is the result of combination. Discrete option and y-axis, we mentioned frequency, so this is the skeleton frequency, again frequency but continuous. So the difference, and we can always plot the histogram by certain categories. By gender, let's plot the histogram, and we have a specified gender and total. This is bin, so this is the continuous result of treatment as if we have the continuous interval. And we have specified in the other one, we have specified discrete, and again this is the bar graph according to gender. So this is the result of discrete, and let us combine them together for our convenience for comparison, and we'll get the results. So this is when we specify bin, in other words it is continuous, and this is for discrete histogram of discrete observation, histogram of continuous observations. These are, let us now explore density, frequency, fraction, and percentage. And if we focus on our y-axis, there is a loop for it, and this will change the scaling of y-axis: density, frequency, fraction, and percentage. Density, frequency, fraction, and percentage. Now let us manipulate the labeling or manipulation of axis. So this is our default one. We have used connected plot type, and here x scale alternate, and when we alternate the axes, the alternate x-axis is activated or used, and next one x alternate, and y scale is also alternate. Now we are going to use both the alternate axes. The other one is x alternate and reverse, so x will be alternate axis, and its labeling will be reverse from right towards left. The default is from left to right. And the other one is x alternate reverse, y alternate reverse. The 0 will coincide over here, and from here top to bottom for y, or ordinarily in general case we have from bottom to up. And similarly for x, it is right to left. Now let us combine them. Did we use all of them? Okay, let us combine them and see it for ourselves. And I margin 0 it is. Okay, this is the result. And again, if we combine them and if we specify holds 4, so at the fourth block it will be empty. And if we specify I margin 0, if possible this margin will be reduced, because this at this point we don't have any labels, so they will completely collapse. So this place it collapsed, and we can further combine them together. And actually we are preparing a base for another example. We will employ this result. Let us drop them all. So this is the result. Now we can alter, scale it differently or as per our choice. And let us see another example. Actually the previous one, manipulation of axis and scale. That was the background for this graph. Okay, let us see. We are connecting export and income, and these are the scales, alternate axis scale. Fine. Similarly, we are going to draw the histogram of export, and this is the scale, axis scale, alt and reverse. Fine. And this is the result. Due to this axis scale alt and reverse axis scale, we are taking the alternate axis and we have reversed the leveling. Now let us use the other one again, histogram of income this time, and we are going to y scale. We are going to alt and reverse, alternate y axis but reverse, and we can combine them all and we can give this look. We can get as artistic as possible based on our requirement. So this is the result, fairly simple one. Now let us move to another plot type. It is graph two-way area plot, and this is also a very simple graph. Let us see how does it work. We are going to draw the area graph of income and export. Export is x variable, income is y variable, and we get this result. And if we use the same variables but the different plot type connected, we get the similar result and we can compare it. So we get the shade beneath the line. So two-way line plot with area shading. So the area is shaded. And these are the options that we can use: horizontal, vertical, see missing, whether we want to connect the missing observation or not, base, and these options. And let us see. So these are the area options. So treatment of this area, we can fill it with different colors, the outline with different colors, its patterns, and so on. Now let us see it by the help of example. The color should be red, fill color is green, we fill it with green, the border color is red, intensity is simply 12, and if we increase it to 30, we will see sharpness in the color, and this is the result. When we increase 30, we get it more dark. Now let us see, manipulate the base, and base we have used this also. Let us summarize the income and get hold of its mean, and then we plot that area graph of income and export. We have taken the mean of income, we have generated this value, and we are going to draw a line of mean of income. So we are basically trying to find the deviation from mean. So income y variable, export x variable, and this is the line. This y line represents the mean of income. So this is the mean of income. So the portion above this line, above the mean of income, it exceeds the income by this amount, and the portion below the mean income, actually it is deficient by this amount. And if we combine this together, we'll see the result. Now let's see connect missing options. If we specify the connect missing no, so the missing observations will not be connected, and this is the plot of income and expenditure. So the missing plots, they are not connected, and if we connect the missing observations, we will get a smooth graph. And to locate the missing values, we can combine them and we can compare them. So these are the possible places of missing observations. Now let us compare different types of plots. So drop line, we are going to use the drop line, and so this is the result of drop line of difference and symbol number. And if we take the area of difference and symbol number, we get this result. And if we use both of them, we get the combination of these results. Find markers will represent it over here. And to track the changes, we can see this result. We started off with this result, followed by this, and when you combine it, this is the combination. This is again a fairly simple one. Now let's move to another plot type. It is two-way area, range but area, and this should also be very simple. The range requires three variables, at least three variables: x variable and the range variable. So high, low, and close. So for this close, we have this amount of high, upper portion, low, the lower portion, and the area in between them is filled. And these are the styles or options that we have manipulated. Replace high by some amount for missing, and let us see what happens if we specify. So we want to specify see missing no. So we want to connect the missing values, and we have or something to be missing, and we see their break in between. Okay, now let us combine them together and look at the breakpoints. So these are the missing points actually, and these are the options for this R area as well. And again, a fairly simple options: vertical, horizontal, see missing, sort area options. We can manipulate, fill the color borders of the area, and we have built about it in our previous graph as well. Let us drop them all, and this is it for this tutorial. We have covered these plot types: two-way bar, two-way r-bar, two-way histogram, two-way area, and two-way r area. So it's time to thank you all for your precious time. Thank you very much for your time. Thank you very much, Econometrics Melody.